Thanks for joining us for the next hour to learn how to use the Yocto build system. My name is Ofer Austerlitz. I'm a VariSite VP of Sales. With me is our software expert, I would say the master of Yocto, the protector of the Linux penguins, Mr. Pierluigi Passaro, simply known as Pierre sometimes. While Pierre will run the main show today, I will take just a few minutes to make a short intro on VariSite and our solutions. So just briefly about VariSite. VariSite is today the leader in system on modules designer and manufacturer. We were established 17 years ago. We practically target all the embedded product segments. We are today just beyond 120 employees with a customer base across the world for more than 4,000 customers and production that are practically made all internal inside the VariSite, giving us a lot of flexibility to support our customers and optimize our solutions. We're selling today over 1 million units per year. We have the headquarters as well as the production facilities in Israel and additional local offices in Germany, US, and Italy. As I mentioned before, we are today considered the leaders in the ARM-based system on modules. We have the most diversified ARM-based products with extensive longevity and compliance policies, including the ISO 9001, but also 13485 for medical customers. We are today the only SOM vendor that was selected by NXP. It's alpha partner for the entire IMX8 product line, including the Nano, 8M Nano, 8M Mini, 8X, Quad Max, and the soon to come 8M Plus as well. So while the focus this time will be on the Mini, we practically have a full portfolio of a pin-to-pin product families. You can naturally build a Yocto on top of each and every one of those. You don't have to use a very high-end kind of a processor like a quad-core with a multimedia or a video acceleration inside. It can actually run also on the IMX6 Ultralight that you can find on the top right on the pin-to-pin VarSOM family. You can scale it up very easily with the same carrier board that is designed by you on the VarSOM 6UL to the different processors that you can see here, ranging from the previous IMX6, single, dual, and quad-core, up to the new IMX8M Nano, Mini, 8X, Quad Max that you can see here, and the soon-to-come 8M Plus. We have additional family that we call the Dart pin-to-pin. That is a bit smaller with board-to-board connectors at the back. That is also scalable in between the different 8M processors, the Mini, the 8M, and the Plus. So those two pin-to-pin families giving you practically the scalability to move from one processor to the other without changing your hardware design. The focus today and what Pierre is going to present, a few examples that we run on top of the 8M Mini. It is one of the most flexible solutions that are available today, practically covering most of what used to be the IMX6 family with all the multimedia accelerators inside, both video encode and decode, graphic acceleration up to quad-core, as you can see here, 1.8 gigahertz that can run together with a real-time coprocessor, and additional features that can practically support all the interfaces that are today used in most of the embedded products, including camera inputs, display, USBs, gigabit Ethernet, PCI Express, and additional connectivity on a certified Wi-Fi dual band and the Bluetooth that you can find here. It is relatively small. We have two form factors, as you recall from the previous slide. Both the Dart and the VarSOM are supporting this one. industrial grade and both Linux and Android operating systems. So this is just a small intro. I will move now the presentation to the master. He will take it from here. And if you have more questions later, also to, let's say, to more general VariSite solutions, be open to send them to me as well.
Hi, everybody. My name is Pierluigi Passero. I'm part of the R&D team of VariSite, and today I will take care of explaining you what is Yocto, why we are talking about Yocto, and what you can actually do with Yocto. Let's start from the available BSPs that we usually provide for all of our platform. First of all, you can check on our wiki. We have a dedicated wiki page for this SOM, as for all of the other SOM, where you can find all the available BSP. Today we will focus on the first one, that is Yocto, but we also have Android, Debian, BootQt, FreeRTOS. For who is not aware of the various details, let me just do a quick overview. Android is the same that you can have on your mobile phone. Debian is a Linux distribution, usually available for several PCs, quite stable, very stable actually. BootQt is let's say, a flavor of Yocto, mainly managed but Qt theme and oriented to the Qt graphics library. FreeRTOS is the BSP that is supposed to be running on the Cortex-M4 that is inside the MX800. Quite often the customer asks us why choose Yocto or rather than Debian rather than BootQt. Let's say that BootQt, as I said, is much more Qt oriented if you are going to use Qt, that is a graphical framework. So let's focus for a while about just Yocto and Debian. Both of them share most of the kernel stuff and low-level stuff. What I mean is that the kernel from a binary perspective and the U-boot, the bootloader, are the same, but let's see from a user perspective what will change. Mainly, something that can quite easily is the user experience. People that come from a Linux PC are very familiar with Debian and can easily upgrade to use one of our BSPs for the machine, for the SOM. Yocto is quite a bit complicated compared to with Debian, but has the same functionalities. Also, with Debian, you can access several packages from the Debian repositories. Here, there is a limited set of packages, much more oriented to the embedded world. Two important aspects are the build flexibility and the build time that are based on the same base. Basically, in Yocto, the packages are built from scratch. So on one side, you need time to build them, but on the other side, you can configure them. Debian, just download them from an external repository and they come pre-configured. No chance to configure the Debian packages. Also, the code optimization is much more referenced in Yocto, and Debian just provide general optimization for the architecture that you're going to use. Another important aspect is the scalability. Yocto is designed for embedded systems, so it aims to be very, very efficient and very, very compact. You can usually have a reasonable file system in 300 megabytes, but Debian is for PC. It's mainly for PC. It's much more usable maybe, but the target is not less than 1 gigabyte of disk space. In our case, eMMC. So now let's proceed and let's start talking about what is Yocto. Yocto, in its original form, was called the Open Embedded. It is a project born more or less 10 to 15 years ago, but this concept has remained the same. There are a big set of scripts that are written in order to create specific packages and specific build instruction for several sources. Sometimes you can also hear about POCI. POCI is the reference distribution that was originally included with our embedded, and that now is the part of the Yocto project. Yocto is more or less a kind of umbrella that collect several way to build packages and to organize the build of these packages in a final image for your target. When you start dealing with Yocto, you also need to consider that you have to build everything, and so you need a kind of build machine. Usually, the suggested approach is using Ubuntu, just because it's one of the most used distribution, and so you can find a lot of support in case of problem. 60-bit is mandatory. Up to you if choose a virtual machine or a real machine. This is the mandatory thing is that you are using at least Ubuntu 16.04 and 64 bits. One little suggestion is to always use LTS version that are the 16.04, 18.04, 20.04, because they are the most tested from the Yocto community. To speed up the build process, 4 core are suggested, and just remind that whatever you put in your building machine, Yocto will try to use it. So the more core you have, the quicker things will be done. But also remind that the more core you have, the more RAM you will need. So for a typical configuration of 4 cores, at least 8 GB of RAM are required, plus some swap area in case of emergency. Once again, just remember that this is a suggested configuration. You can run with 1 core, it's fine again, but you will be slower. Mandatory instead is the required free space. We are talking about not less than 150 gigabyte of free space. Suggestion to use an SSD just because of the speed, but it's up to you. You can go for a mechanical one and you will be just a bit slower. Another mandatory thing is the internet access. This is nothing that you can avoid, because you are going to download all of the packages that you need to build. Sorry. Okay. And let's try to understand now how Yocto started the build process and how it manage all of these tasks that need to be performed in order to have an image. This is a general workflow of what Yocto is planning to do. We will go through this image in details for the steps within the blue part, but let me focus your attention on some specific area. This is what is usually called the input for the configuration side and metadata side. Here you will find that the user has the capability to configure the build. We will see later how to do it, but this is one of the key aspects of Yocto. You can configure your build according to your need. As I said, Yocto is a collection of scripts that are usually called metadata and are provided in form of bit-based script, a kind of Python language, but you will find later during the explanation how they are involved. Also, there is the machine BSP configuration. That is a kind of configuration file showing the architecture of the machine, the way you are going to introduce the optimization for the hardware and whatever. Finally, there are some policy that are used by the build system to manage the package building. This is one aspect. Another important aspect, as I said in the previous slide, is that you're going to download the sources. And the sources will be mostly available from the web through specific URL that will be present in the recipe available in the scripts. And you're going to download them. You can also have local projects, local repository, so you can download directly from your machine, but usually you have to have the internet connection and download these sources. Take care that several of these sources are under configuration control. So the software configuration manager in terms of servers need to be accessed in order to download these packages. This is the bit-based aspect that actually describe the way Yocto build images. And to build the images, it will generate some packages that will be used to generate both the images and the SDK. But let's try to go step by step and analyze this sub-portion of the build of the Yocto workflow later. The very first step to start, as I said, was the wiki. And in our wiki, you will find a set of instructions for your Ubuntu machine to configure the preliminary part. This is a setup. You can configure the list of packages that you need to build the Yocto image. You have to create some folders. You have to download some utility like repo. And finally, you are going to download what is called a manifest. What is a manifest? The manifest is just a list of reference servers. This is the manifest that we use for our IMX8M mini Yocto build. So here you can find a list of reference servers that will be used to populate what are the local folders on your machine, and that will host the list of scripts that will be used. Why an XML? Why putting all of this revision? The XML is just easy to use from a script perspective. The revision came because several versions of Yocto are available. Yocto provides 2 different releases every year, usually in April and October. And every time that a new release is provided, NXP and then us provide updates to our BSP. So we need to maintain the previous version, but we also need to go with the new one. This is why you have both the server, the revision, and the local path on your PC. These are the local paths that will be used on your PC when downloading everything. So summarizing, the last command that we have seen here will create a list of folders in your build machine that will be the sources, the source directory. But also now start with the real configuration. Till now we just downloaded the build scripts. We need to configure those scripts in order to have the build for our system. Let's say that we have a specific syntax. One parameter is the machine to be built, the other one is the distribution to be used, and finally we have a build folder where everything will be done. The most important fact of these aspects now is that in the build directory you will have the conf folder that will host some configuration file. as I said before, part of the Yocto workflow rely on configuration files that are used to configure all of the aspects of Yocto. So let's start analyzing, first of all, the Yocto sources, the Yocto source directory. Here you can find a list of folders that are commonly called layers. When we started with Open Embedded, let's say 10 to 15 years ago, Open Embedded was a single blob of images, of a recipe, but with the years they keep increasing too much. And in the end, when Yocto project was born, they decided to split for, let's say, subjects. So there are recipes in the BSP layers that just take care of the machine. There are this recipe in the distro layer that just can take care of the distribution. I mean, how the package, which are the wanted packages and how they are supposed to be configured. Then there is a list of software layer that just provide the list of recipe that allow to build a specific package. This is managed automatically during the download phase, so you don't need to care about the layer. They will be provided to you once you download everything with the script that we provided in the wiki. So one of the parameters that we used in the previous version, in the previous slide, was the distro. What is the distro? Much more than a distribution, here is intended as graphical backend. And for graphical backend, we intend whatever we are using to access the graphics capability. Those are the distro available for IMX-A10 family. FSL IMX Wayland and FSL IMX X Wayland. Wayland, for who is not aware, is a kind of successor of X, where X is the previous graphical servers that were present in almost all of the graphical Linux machine. X has been designed several years ago, and now is becoming a bit, let's say, old. And the Wayland is trying to compensate all of the problematic aspects that arise when using X. It's a kind of redesign of the graphical aspects of the video applications. So on NXP side, the graphical application are only provided using Wayland. And to keep compatibility with previously developed application written for X, X-Wayland is a kind of X emulation in Wayland. You will not have access to the graphical acceleration because they are not available for X, but you will still be able to run also X application. Just for sake of knowledge, I also reported the other two distribution that graphical backend actually that are not supported by IMX-A10 family, that are X11 and the frame buffer, where frame buffer is the direct access to the frame buffer area. Whatever you will choose, in any case, this will just provide you the way to access the graphics, but you're supposed to choose a graphical library in the end. I reported here the most used Qt. I expecting that does not need that much presentation. It's just the famous Qt. GTK is an alternative to Qt as long as you are just looking for graphical aspects, because while Qt cover graphic connectivity and whatever, GTK is just graphical aspect. SDL for who, like me, it's quite old, is something nice. It was born several years ago, was developed for Linux, was accessing the frame buffer. Now it's supposed to be compatible with Wayland, was highly used in the games world, but still usable for a very nice graphical application. And in the last year, I've seen that Little VGL, a library that come actually from the Cortex-M world, has been ported to Linux and can be useful for a low target system that does not rely on specific aspect of the graphics and not require that much. So let me check for a while about questions. Okay. Okay. Okay, I can see a question about license. We can talk about license, but I suppose in dedicated session. Believe me, the question of license is quite complicated. You need to remember that GPL come in several flavors. GPL is the new public license. Qt moved in the last year from GPL v2 to GPL v3. Just let me say that the GPL v3 changed a little bit and ask the provider of the sources to let the final user fully accessing the system. If you're going to build a machine that you want to be closed, this is not for you. But you can still buy the commercial license and close your system. Other questions? Let me check. Oh, for several question for several person that asked about this presentation will be available on our website. We will take maybe some days, but it will be downloadable and available from the website. Which manifest to use? Okay. You don't need to care about the manifest. If you follow our instruction in the wiki page, you are supposed to download the right manifest. Actually, when you run this command, you're actually saying that you want to run this specific manifest, IMX for 1933, blah, blah, blah. So don't need to care about this. Okay. Let's see that I will answer further question later. For now, let me go on just to be sure that we can close everything within the hour. So, okay, let's move this here. Let's start with the build now. When you will start the build, you will run the command bitbake. Bitbake will be used to do almost everything in the Yocto world. It's the command that activates the build process. Here we provide as an example the build of the free-scale image GUI, but you can also build a specific package only for whatever you want to do. There are several options with the bitbake, including tracing the environment variable that are used during the build without actually doing the build. It's a kind of dry run. When you will start building, you will see, I reported here my screen when building the image. You will see that there will be a phase that will actually check for all of the scripts in terms of syntax and check that everything is fine from a syntax perspective. It will report you statistics about how many recipes have been parsed, which have been skipped, because maybe they are not compatible with the configuration you require. But very, very important, you will have a list of all of the layers that are involved. Here you can see Meta, MetaPocky, MetaOA. I'm talking about this part. And for each layer, which revision you are using. So if you remember what we said in one of the previous slides, the manifest reports the list of repositories, and also the revision of each repository. Here you can have a feedback of what's going on, and from our perspective, it's a check that we often ask to the customer when they experience build problem, because we need to be sure that we are talking about the same sources revision, okay? Once this data is provided, then actually start the build. And when the build starts, Yocto starts doing a series of tasks. In my configuration, there was I'm using 4 cores with hyperthreading, so 8 threads at time, but each thread is doing a specific task. Here you can see that the binutile package is under do fetch task, and the same for the glibc package, do fetch. The get text is under do configure. The encurses is under do compile task, and so on. The latest one, the Linux libc, is under do install. Basically, what is going on is that all of these tasks are the subpart of this, that is the same image that I've shown when we started showing the general Yocto workflow. The very first entry point is the source fetching. So, as I said, you're supposed to download locally all of your sources, all of the sources that you need for your build. Usually, customer report some specific issue that are mainly network stability and firewall problems. What I mean, most of these sources, if I need to say how many, I don't know, but basically all but 2, I mean U-boot and kernel, comes from external repositories that are beyond the community control, generally speaking. So in this phase, you can experience problem connecting to those repositories because maybe the servers are down or there is a connectivity problem somewhere in the middle. This is what I mean by network stability. Another problem that sometimes happens is that when you need to download from SCM, so I mean from Git server rather than SVN server, on your side, if you have a firewall, you need to take care that the relevant ports are open. And sometimes they are not by company policy. In these cases, you need to fix the problem on your side with your IT team. One of the possible alternatives is doing the build in what is called a demilitarized zone, in DMZ, and outside your company firewall in order to allow at least the source fetching. Once the source fetch is completed, you will pass to the patch phase. Why we need to patch software that we have just downloaded? Mainly because sometimes the software officially as is, it's not suitable for embedded builds. Sometimes may need some patches to be more general. Sometimes they need patches to extend capability. Sometimes you may need patch because you don't like the standard configuration, you want to change it. Generally speaking, this phase is quite easy, and we have very, very minor reports of problem here, almost always related to changes not correctly done on customer side. Basically, you don't need to customize a patch or a recipe. But if you are going to do this, you need to take care that the patch must be aligned with specific version of the package that you're going to download. Following this phase, there is the configuration compile and basically the building phase. Here we have one of the most critical parts of the build, because all of the resources of the machine will be used, all. Unless you cut them with specific configuration, you will use all of the cores and all of the RAM. This has a side effect, because if you have several cores, you can experience low RAM availability, because each core will run different aspects of the build. I don't know if you remember when I was talking about the slide 19, I said that every single package was performing a specific task. So each core is doing different stuff and is requiring different memory. One of the more critical tasks is the linking phase, because all of the output, all of the objects will be put in RAM to link them. If more than one core is doing the link phase, maybe of huge packages, you can experience problem with the RAM and the build may crash. That's why if you don't have some RAM or enough RAM for everything, try to at least plan a swap area on your disk. It will be slower, but will not fail. And also keep monitoring the RAM usage during the Yocto build. Just the first time, once you will be sure that this is not a problem, you can go on and leave everything as is. Okay. Once done with the compilation phase, the packages need to be split. What I mean, the binary have been already generated by the configuration phase, but they need to organize it, not in a single set of files to be copied, but splitted in several subpackages to be better managed. I mean, if you have some binaries, they will probably be part of the package name as is, but the package has also a subpackage called the -lib that will just include all of the libs, and some configuration files may be put somewhere else. I mean, this is just part of the policy that Yocto used by default when building the system, and you're supposed to do almost nothing unless you are writing your own recipe for your own packages. Just take care and start from some references to have a common understanding of what's going on. This phase will generate a long list of packages that will be used later, but will be part of the package feeds pool that Yocto will reference for the next phases. This is what is usually called the do install phase, if referring to the slide 19. Okay. So once the package building has been completed, finally we can generate the image. This process basically relies on the presence of all of the packages that will be merged together to create a kind of root file system, and the root file system will be somehow used to create the images that you're going to burn on your final target. Usually also this phase, it's quite easy. You may experience quite a QA issue, quality assurance issue, whenever you have two packages providing the same outputs and Yocto say, okay, I have them, each of them is providing the same output. I don't know which package I have to choose for a specific file. Even in this case, most likely you are customizing your build and you need to take care that Yocto has its own policy, and you need to manage them correctly. Okay, what will happen when the build complete is something like this. At the end, you will find that you will get the prompt again with maybe some warning because of some minor inspection that the quality assurance has been done from Yocto. But you get the prompt. This is the moment in which you can understand that the build is completed. How long it took, it depends on the resources that you have allocated to your build. Let's say that generally speaking, on a fast machine, you can go low to 2 hours. On a very slow machine, you can take even more than 8 hours. It depends on the resources that you can use on it. And once we have all of the image, we can finally generate our recovery SD card. The recovery SD card is basically something that we can use to start our system, our final evaluation kit, but we need to generate them with some additional scripts rather than those that are just present in the image. We provide in our wiki the instruction. This is the one that we use by default to create the recovery SD card. On the wiki, you will find some additional option that may be useful. But what's going on is that in the end, you will be able to have a recovery SD card that you can plug in our evaluation kit and just power on. Just be careful with the boot switch. All of our SOM can boot or from external SD card or from internal eMMC. If you want to switch between one or the other, you need to change the deep switch that is controlling. Int is stay for internal, X for external, and that's it. Once you have the recovery SD card ready and you installed it on the eMMC, you can start testing at least the hardware. We have a dedicated section in our wiki for the how-tos where you can check how to test the audio, how to test the UART, how to test the I2C, something that does not really require you to build something custom. It's just something standard. And okay, by default, our console will be accessible by the debug UART here. It's actually a converter micro USB to UART, and we just have a single user root that you can use to access and check everything from console. This is the standard part, but generally speaking, this is not this useful if you're not to write your own application, because you don't have any specific application here. So what is very important is to customize the image, allowing you to do whatever you want to specifically do for your project. How this can happen? The easiest way to customize your build is deal with the local.conf file. If you remember in slide, so let me check. In slide 15, well, in the conf directory, there is also the local.conf file. So this file is actually one of those that can be used to configure your build. It's a standard text file where you can set the download directory. You can add feature to your image. Just remind that feature means set of packages. So for example, in our wiki, you will find that to add the virtualization support, you need to add something like distro feature append virtualization. And for example, if you want to add the bug support, you can copy this from the wiki and have support also for the Eclipse rather than Qt Creator and whatever. Finally, you can also customize the packages. As I said, one of the advantages of using Yocto is that you can customize the way you build the packages. So, for example, this is how to add native SQL support to the Qt base package. Okay, and this is how the local.conf will appear. Just a sequence of a string. Then specifically here you can see the feature added, the image added, the packages added, the distro feature added, and the package customization. Okay, once you customized your image, you are finally ready to start building your application. And to do this, you need an SDK. What is an SDK? An SDK, it's the basic version of an SDK. It's just the cross compiler, and you need to generate it accordingly what you have in your file system. So this is the very final step when building Yocto. You need to generate an SDK that is compatible with your file system, and there are a few options available. This one, the meta toolchain, is the very basic one and provides just the compiler, but not that much in terms of tools. For example, if you want to have a toolchain that also supports Qt, you also need to deal with the meta toolchain Qt5. It's just a different approach. And we provide the toolchain providing also the Qt scripts. Generally speaking, a good approach is generating your SDK starting from your image, because in this case, all of the library in the image will be also available in the SDK, and will avoid situation in which you are missing some libraries from the SDK. This should cover merely everything. Just let me check here. Okay. We provided you a list of references about what we talk about. These are part of our wiki, external references, and here you can find, and here you can find also the external reference to the Yocto project. Let me leave the presentation to my colleague Ofer for a few words, and then I'll be back for the questions.
Yeah, I can just switch to the next slide. So here, actually, we wanted to highlight a very good partner that we have. In case you would like to have a deeper hands-on training, this is also the name of the company, Handson Training. So they can actually provide you much deeper training on several of our products and platforms, from a few hours up to a few days, either remotely or on site. So you have here the contacts of this company. They are practically the partner of VeriSite for deeper trainings that you can actually use and leverage in the future if needed. Can you switch to the next one, Pierre? And if you forget anything, not the final questions, this will come in a minute, but the previous slide here. So here you can actually find a few contacts that you can use. Everything is practically available inside our website, including the links to the wiki and to the portal under the support page. And just remember verisite.com. If you would like to send an inquiry of one of our products, everything is practically available through the website. We will naturally share with you the presentation, including the recording of the presentation itself. And there will be also some discount coupon to the ones that actually attended this webinar. In case you would like to purchase a kit, there will be a special coupon that will be provided to you in the very next email that you will get following this webinar. There will be now a short final session of questions and answers, Pierre. So I bring it back to you.
Thanks, Ofer. I will start through the question that I've received. The first one asks, if I want to use Python 3 instead of Python 5, what I have to do? Okay, this is a common question, but let me explain that the first thing that I would do is check which Yocto version is actually including Python 3.7. Why? Generally speaking, because the dependencies of each package is tailored within the distribution itself. Yocto comes with several distributions, as I said, twice per year. So if your target version for Python is not available in, let's say, Sumo, but in TAD, I would go for TAD, assuming it is available. Let me also clarify that in this initial approach, since we are receiving the main BSP from NXP, and then we are customizing it for our board, not all the Yocto version are now available. So we moved from Morty to Sumo, and we are moving to Zeus. So some intermediate version are missing. You can try. I mean, the Python is most probably provided by the Pocky layer, and the Pocky layer you can try either picking the recipe from a newer version or try to pick the whole Pocky from the newer version. The point is that most likely you will experience problem during the build because of the dependency. Each BSP provided by the community is tested against all of the other BSPs. So if you introduce a change, most likely you will introduce a change in the dependency lists, and this can lead to errors. Okay. Okay, someone is asking how to get in touch with the software developers. We provide you a portal, a customer portal that you can access from our website. You can register, and we provide a free service of ticketing. So you can ask your question. We can provide support, and we can share our experience with you and help you to do the customization of your BSP. Okay. I have a question asking if just adding Xwayland as distro enable graphic acceleration. Actually, either if you use Wayland or Xwayland, the acceleration are always provided only for Wayland. So if you want to use an X application, you can use it, but you cannot access the graphical acceleration from the X application. You need to write a Wayland application. Okay. I noticed 2 to 8 hours build time. I assume this is the first build and incremental from there. Okay, this is a good question. I've been requested what will be about the next builds. Let's say that if you are customizing an already completed build, you are supposed to just build only the packages that you somehow changed. So you are going to reuse all the do fetch phase because you are not fetching anything else, most likely. or maybe just additional packages that you added. But let's say that if you spend 8 hours to build the whole image, I'm expecting that to add one package, you will spend probably 10 to 15 minutes. Okay, it's just a change in the addition of the package, or even eventually in the customization of the package. Okay. Okay, I have a question, a nice question about the tool chains. The question is how to manage the case where two toolchains are needed, one classic for building Linux and another for a bare metal coprocessor. Actually, they are two different toolchains, and Yocto just take care of the Cortex-A, not of the Cortex-M. If you look at our BSPs, you will see that when building the FreeRTOS part, we point you to specific ARM compiler available online from the ARM website. We just rely on ARM for bare metal compilation. Okay. Oh, this is another good question. Docker and Yocto. We released the Docker support for all of our recent Yocto BSPs. You will find a guide, a dedicated wiki page about how to enable it. Basically, we provide a reference image and the instruction to enable the virtualization feature in the local.com. That is what you're supposed to do. We tested with basic test available from Docker website, and we provide also a reference implementation of some REST communication between server implemented directly on the machine, so you can verify whatever is available now. Okay, I think the time is out.
Last one.
Sorry?
I said last question.
Last question. Okay. Let me check. Okay, I have a question that I'm not sure I really understood. I've been asked if it's possible to split an image in subpackages, I suppose. I'm not really sure. So basically, when you build your image is a kind of collection of packages. So you can add or remove the packages that you want, and you can also access directly those packages from the packages pool that you have. Not only, if you want, you can download those packages on the target and install them on the target. Just remind that packages have dependencies from other packages. And so it may happen that you cannot install a specific package unless you previously installed its dependencies.
Okay, so thank you very much, Pierre, and everybody attending this webinar. Again, everything will be practically available for you as soon as you will get the email, and also on our website. Have a good day, stay safe, and be careful out there. Thank you very much.